Okay, I'm going to go through this pretty quickly, so pause the video where appropriate and take some notes. Before I start answering this question about the Norman window, let's actually go to Desmos and see what's happening here. Here we got a Norman window where P is the perimeter. For your problem, P was 90. And we could change the radius of the circle. And you can see that the area changes. But if we set R to give the maximum area, it turns out that R has to be P over pi plus 4. Let's see how we arrive at that conclusion. So we'll go back to Wyzant. So here's the Norman window. We're going to call this dimension a little r, and which is the radius of the semicircle, and L will be the length of the rectangle, one side. Okay, so the dimensions of the window, we want to find that give the greatest possible amount of light. That means we want to maximize the area of the window. So the area of the semicircle, the area of a circle is pi r squared, but we've got a semicircle, so it's 1/2 pi r squared. And the area of a rectangle is length times width. This dimension here is 2r times L. So there is a formula for the area of the Norman window. But we'd like to take the derivative of that with respect to maybe r. So we somehow have to eliminate this L. And that's where the perimeter comes in. We're told that it's 90, but I'm just going to use the letter P to show that it doesn't matter what the perimeter is, the value of R that gives the maximum area is P over the quantity pi plus 4. So the perimeter of the semicircle, the perimeter of a circle is 2 pi r, but we only have a semicircle. So this distance around the circle is pi r. Okay. Now for these dimensions, we've got 2 L's and 2 R's. We're not using the standard formula for the area of perimeter of a rectangle because these R's aren't part of the perimeter. So there's your formula for the perimeter of the Norman window. So if we want to solve for L, we can isolate the term containing L, end up dividing by 2. So there's a formula for L. And we want to substitute that in to this formula so that we have A depending on R. So there's our area function depending on R. We can simplify that a little bit, which I've done on board 2. So distribute this 2R, or these 2's cancel out. So we get PR minus pi r minus. And now, finally, we'll take the derivative, set it equal to 0. So here we are setting it equal to 0. Solve for r. Well, it turns out 2 pi r minus pi r is 1 pi r plus 4r. Factor out the r, divide by the coefficient of r, pi plus 4. There it is right there. Okay. Now you could take the second derivative and substitute in this critical number to show that you always get a negative number. So this particular critical number is giving you a maximum area. I didn't go through that step. And we can also substitute this expression into the formula for L right here. There's R, there's R. And when you end up simplifying that, you find out that the length or the width of that rectangle is also P over pi plus 4. So the answer to your question, since P is 90 over pi plus 4. If the perimeter was 70, it would be 70 over pi plus 4. Okay, there you go. Hope that helped. If you have any questions, post a comment.